All right, so let's see how we would approach this problem. All right, so this is number 17, and we have, first thing we said is get rid of the x, right? We want to isolate the radical. Let's go ahead and isolate the radical. Can someone say, can I do it? Yeah, absolutely, go for it. Please. Go for it.
She heard 18. Some people just know. It don't matter.
Hold on.
Oh, wait, my bad.
Hold on. You messed it up. Take your time. Be careful.
Well, it's fine.
Uh-huh. Okay. Okay.
Oh, yeah.
Well, it depends on what you need to get. It depends on what you need to get. There's only one thing that's going to work. There's only one thing that's going to work. Oh yes, oh yes, oh yes.
So do you want to put it in this original?
Let's pause here. Let's see where we're at. Let's see what we got going on here. Thank you so much. Thank you. Fantastic. Thank you. All right. So let's see what's going on. Okay. So first thing she did was she subtracted x from both sides. If you subtract x from each side, you would arrive, here's this line here. Does everyone see that? And then, instead of having negative root 2x plus 5, we decide to have just the positive root. So she divided both sides by negative 1. What's another way you could have done that? Instead of divide by negative 1 to change it. So divide by negative 1, you could multiply by negative 1. It doesn't matter which way you think of it. That would make this positive root 2x plus 5. And then now she just has x minus 5. The reason for that is when you multiply divide by negative 1, it just changes the sign. You can just change all signs to positive x and to minus 5. Right? If we actually broke this up to see this, negative x plus 5 over negative 1 if we broke this up, we would have negative x over negative 1 plus 5 over negative 1. But we're allowed to break up fractions over the same numerator into partial fractions. And then what's negative x over negative 1? Just x. And what is plus 5 divided by negative 1? Negative 5. So that's how she got here. X plus negative 5 or x minus 5, how you want to say it. Then we want to get rid of the radical. So to get rid of the radical, we square both sides. Squaring both sides, we get just now the radicand 2x plus 5 equals, now this squared. This is where, if you can't see how she got this, you need to actually write x minus 5 times x minus 5. And you need to go ahead and FOIL it. X squared minus 5x minus 5x plus 25. Does anyone need to see the FOILings? We're all comfortable with that, the FOILing, the x minus 5 times x minus 5. You FOIL. Now we're here. Now it's a matter of, okay, do you see that she just simplified here? She did negative 5x minus 5x and got negative 10x. Do we see that simplification? Yeah? Okay. And now she wants to set equal to 0 because now she's at a quadratic. Now we're here. Negative 10x minus 2x, negative 12x, and then 25 minus 5 is 20. And then how do we factor this? We say, okay, what factors of 20 add to negative 12? Let's see. Is this supposed to be positive 25? So you're okay with this being 25? Okay. So then what she did was she said, okay, I'm going to subtract 2x and subtract 5 from each side. 25 minus 5. Positive 20. So now we got a quadratic set equal to 0. So this is still an equation in the next line, right? Still an equation. And now x could be 10 or 2. Could be. These are the proposed, right? We have to check these now. We do have to check. Because we're solving radicals, yes. Let's go ahead and check. So now where do we plug it in? How do we check? Plug it in the original. So we're going to test this. Plug it in the original. So we have 10 minus root 2 times 10 plus 5. Does that equal 5? Christian? Please help out. So if we simplify this, 10 minus root 20 plus 5. Ten minus 5 equals 5. So 5 equals 5. So this checks off. So we know that this is definitely a solution. But the 2 doesn't work? We'll see. I don't know. I haven't checked it yet. Let's see.
Check it in your head, it doesn't look like it works.
They both might work.
So if I test 2, which for some reason that didn't move over.
I was telling you it don't work.
If I test, so you've already tested it?
It might be something it don't work.
Oh, you did it? What'd you do? What'd you get?
Did you test it?
They don't check.
Let's see. Let's see if it works out.
Might work.
Let's see if it works out.
I don't think it did. Go ahead.
Why is there so much chit-chatting going on? I don't understand. I don't understand. Is there a problem? Okay, so we plug in 2. So 2 minus root 2 times 2 plus 5, does that equal 5? Say no? Let's see. 2 minus root, what is this? 4 plus 5, does that equal 5? 2 minus root 9, does that equal 5? That's a sad looking 5. 2 minus 3, does that equal 5? No, negative 1 does not equal 5. So we can definitely say this is not a solution to the equation. Any questions about this problem? All right, let's try another one. Now we're going to try to answer the question that they were trying to answer is how do we solve the double radical equations? One that has 2 radicals. And the process is very similar. It's very similar. You just keep going. You just keep going. You're going to do it. You're going to square both sides. You're going to have another radical that's still there. You keep going again. Isolate that guy. Square both sides. It's the same process. So let's go ahead and let's take a look at 23. So 23 says the square root of x plus 8
That's it. That wasn't the textbook.
minus the square root of x minus 4 equals 2.
What was the thing
This, hold on just a second. This is section 1.6 in the textbook. Yeah, we're on 1.4, so we're at 1.6. What types of equations? Solving radicals. Going to the exercises. This is number, for that page there, number 23. So this is page number 169. Oh, all right, everything right there. Let's see. All right, page 169 in your textbook. All right, so what do you think is the first step? This is page 169 in your textbook. This is number 23 on page 169 in your textbook. Isolate one of the radicals, exactly. Thank you. So let's go ahead and do that. So if we isolate one of the radicals, let's say I'm going to add, let me add this guy. If I do that, I'm going to have the root x plus 8 equals 2 plus root x minus 4. The reason you don't want to square the as it is written right now is good because you're going to have this really nasty middle term. It's going to say minus 2 root x plus 8 root x minus 4 as the middle term, and that's what we're trying to avoid. So we first isolate one. It doesn't matter which one you isolate. We isolate one of them. And then now let's go ahead and let's square both sides. So we have the square root of x plus 8. We're going to square that guy. And that should be equal to, now this is where you guys gotta be careful. I see some silly mistakes being made by some of you, that you're squaring the entire right-hand side. You're squaring the entire left-hand side and the entire right-hand side. So if I square this, it drops the radical. And now if I square this, this is where I see some mistakes are being made by some of you. So let's do this the long way. Let's actually write it all out as it reads. It's saying let's square this whole value here. Right? It looks like a beast, but this is what it is. So I don't want you guys to make a mistake. I see some students doing is like, okay, this is 4 plus x minus 4, and that's not correct. Yes? Put it in where with what? Yeah. So when you square the left hand side, you have to square the entire right hand side. No, the mistake that the student made on the warm-up problem, the mistake the student made was that they squared before they isolated the radical. Okay, they should have isolated this radical first. They should have got the square root of 2x plus 5 by itself first, and then square it. So even though there's 2 radicals in this problem, we're still looking to isolate one of them. It doesn't matter which one you isolate, but you need to isolate one of them. So you need to isolate one of the radicals. When there's 1 or 2. If there's 1, it's the only one to isolate. If there's 2, it doesn't matter which, just isolate one of them. So you need to do this first. You need to isolate one of the radicals. Then the second step was to square both sides. Okay, this is where I want you guys to be careful. Again, I've seen a lot of students are making the mistake. So it's not just 4 plus x minus 4, right? It literally means this whole thing squared. So it's this. So we have to, what's the process that we learned? FOIL. It's 2 times 2. So the first terms, then outside terms, then the inside terms, then the last terms. FOIL. FOIL. We have, yeah. And the order doesn't matter. Just make sure each term is multiplied with each term of the other guy. But FOIL is a very convenient way to think about it because it's first FOIL means, let's go over that. So FOIL means first, outside, inside, last. First, outside, inside, last. Okay? So the first term, 2 times 2, 4, good. 2 times this radical is just 2 times that radical. 2 of those. Then we have this radical, same radical times 2. I'm still going to write it properly, the 2 in the front. Plus these 2. Now what is the square root of x minus 4 to the square root of x minus 4? Just x minus 4. I didn't have to put parentheses, I just did that just to show that that's this guy here. Parentheses obviously not going to affect anything. So if I take this line here, and continue on the next page. Yep, it just drops the 2. When you multiply 2 square roots, which these are, it just drops the radical. 2 square roots, because let's review that the square root of x, how can you write that in exponent form? what is the square root of x in exponent form? I mean, if I wrote it in exponent form, like if I wrote x to some exponent.
1/2.
Yes, thank you, 1/2. That's why the square root of x times the square root of x is just equal to x, because this is x to the 1/2 times x to the 1/2, which we add the exponents, x to the first, so x equals x. So just a quick review as to why this works out, why square root of x squared x is just x. Good? Are you sure? Like a sarcastic sure? Are we not sure of what? Do we need to review this again?
No, you just did that.
What's confusing? What's confusing about this? It's not? Please let me know. If it is, you need to come see me. So let's continue this problem. I still have x plus a on the left-hand side. Let's not forget that guy. So we're here. All right. Let's keep moving on. I think this is the correct line. I think I copied and pasted correctly. Yeah.
That is correct.
All right. So what do we now? If we keep going, what do we get? We have 2 of these plus another 2 of these is 4 of these. I see some of you are not writing notes. I definitely encourage you to write notes, please. And then we have 4 plus negative 4 is nothing or 0, good. And then we still have a plus x. 4 plus negative 4 is 0. So these, you can think about these canceling, they go to 0. Okay, so now we're here. So now we're at a single radical equation, right? We started off with this double guy. We started out with the double, the top line here. Now we're at a single. Now back to yesterday's lesson. Why did what become x?
The 4 and the x minus.
The 4 and the x minus 4.
You have to combine like this.
Well, the 4's go away to nothing, so the x is still there.
Oh, I
You can drop the parentheses if you want. It doesn't affect anything because it's just connected by addition.
So, yeah,
So what is the big idea here? Isolate the what? The radical. So isolate the radical. Again. So how do we do that? Subtract x, okay? So minus x, and what would that leave us? 8 equals 4 times, Christian, can you please move up to this seat or this seat?
Yeah.
Thank you. All right, so now we're here. Have we completely isolated the radical yet? What's connected with it? How is the 4 connected? All right, so how do I do multiplication? Yes. Very good. 2 equals the square root of x minus 4. We're getting down towards the end here. Let me see if I can fit it all on this slide. Actually, you know what? Let's continue this on the next page. We're right here. Square both sides?
Yes.
That's where we are. So I'm going to square this side, and I'm going to square this side. What do I get? 4 equals x minus 4. Last step. Add 4 to each side. So x equals 8. This is our only proposed solution. I can't emphasize enough now that we have to check. We have to check it. It may not work. It may be an extraneous. So it's like the verbiage is just check for extraneous solutions. Let's do that. So let's go back to the original. This guy, and always plug it into the original. Don't plug it into some line that was halfway through our work. Plug it into the original given equation. So we have the square root of x plus 8 minus the square root of x minus 4 equals 2. Why would it do that? Why did it start off right? What is it, guys?
It'll be x
The square root of x plus 8?
minus
The square root of x minus 4?
equals
Equals 2. Thank you. So then I plug in 8 for x. Square root of 8 plus 8 minus the square root of 8 minus 4. Does this equal 2? Root 16 minus root 4. Does that equal 2? 4 minus 2. Does that equal 2? 2 equals 2. Makes a true statement. So this is an actual solution. It checks off. Anyone need more time on this? You good? All right, so go ahead and with a partner, I want you to try one of these other ones. Let's go with, pick any one, 24 through 26. Pick one of them. Work on it with your partner, try to figure it out. Please raise your hand. Please raise